Given that A is
Mr. Keith,
hello.
How did you find 210 in the previous class? Or in the previous, that.
We added 180 plus 30. And B is an acute angle such that sin A is 3/5 and cos B is 5/50. Find tan A plus B. Good. So given that A is an obtuse, so what that means is this. The triangle A would make, since it's an obtuse, will be in the second quadrant. So this is what it means to be obtuse. So this is A. So I'm interested in this triangle. So place it here. And then the other one, acute. So acute, see here. So B will be placed here because B is an acute. Then sine, we know that sine is opposite over hypotenuse. So opposite 3 over hypotenuse 5. We also know that cos is adjacent over hypotenuse. So now I find the missing side. So 5 squared minus 3 squared, we get 16, which will give us 4. And then 13 squared, 13 squared minus 5 squared, take the square root, we'll get 4. So this will be 12. Yeah, you can rotate to find the other angle. So now here, tan A plus B requires that we find tan A plus tan B and then divide by 1 minus tan A tan B. So what is tan A? So this is going to be -4. So tan A is opposite over adjacent. So we get 3 over -4. Tan B is opposite over adjacent. So we get 4/5. And then substitute. -3/4 plus 12/5 over 1 minus 12/5 multiplied by -3/4. So that is just -3/4 plus 12/5 over 1 plus 2 times 3 is 6 over 20. So that in the numerator, 20 is a common denominator. 4 into 25, so we get negative 15. 5 into 24 times 4, we get 38 over 56 over 20. If you do the addition down here, and then that is 33 over 20 multiplied by 20 over 56. So we get 33 over 56. So the terms which have played the critical role here are the terms obtuse and acute.
Sir,
Hello.
here where the denominator is 1 minus tan A tan B, I don't understand how this is coming about, like how it's been like.
This one's an identity.
Oh, so we just have to master.
Identity is a must. Identities are difficult to understand. We just master that. We use in the near future. Proof sin squared x is 1 minus cos 2x over 2. Proof.
So I'm kind of asking if you could go to the previous page. All right, thank you.
Prove that this is the case. How do we do this? So this kind of proof is it's coming from this identity. Thank you very much, sir. Yes. Yes, thank you. It's only that me using the coding. Yes. That's where it's coming from. Okay. So because it's coming from this setup, for you to prove this, there are two options. You can say, okay, What is okay, let's start with cos. What is cos 2a? Cos 2a by definition is cos squared a minus sine squared a. It's also an identity. From this identity, we change this to sine. So we get 1 minus sine squared a, and then we have sine squared a. So this whole thing here is cos squared. Altogether, we have 1 minus 2 sine squared a. So this is equal to cos 2a. And then we switch, or we take this guy the other side. We have cos 2a plus 2 sine squared a is equal to 1. Then take this the other side. We have 2 sine squared a is equal to 1 minus cos 2a. Then divide by 2, divide by 2. So then we get sine squared a is 1 minus cos 2a over 2. So let a be equal to x. So we have sine squared x is 1 minus cos 2x over 2.
Sir, I have a question.
So this is the method of implementing. So they want to get to handle this place. And the method of implementing.
Sir,
I think just you good to concentrate
I can't get you.
sir, I'm a little bit behind, like where square root of 1 minus cos 2x over 2 becomes cos 2a.
Where's square root of what? We don't use the square root in approval.
I mean the square root there at the right corner, that side where is sine x.
We don't have it.
Now, sir, where is cos 2a coming?
So I said that this one is an identity. Where do identities come from? You have cos A plus B. We say that it's the same as cos A, cos B minus sine A, sine B. So that if these are equal, you have cos A plus A. Then you have cos A minus sine A, sine A. So a plus a is 2a. Cos times cos is cos squared. Sin times sin is sin squared. So the identity is coming here. Okay. Find x. If
Sir,
you know,
sir, these identities, I'm asking for the previous board. Now the identities, they look different, right? Isn't sin 2x equal to 1 minus cos squared x?
cos squared a plus sin squared a is 1.
Sir,
You know,
I didn't follow this properly because which side did you get to prove that? The right or the left side? I didn't see the side you got to prove.
it's not always that you need to pick a side to prove. Some identities like this one requires that you start from somewhere and end up with a given result. Ideally, the whole thing of proof is just trying to give evidence of why you think.
Excuse me, sir.
You
The
know,
question which we add is saying, like the question is saying sin 2x is equal to 1 minus cos 2a over 2. Now, like in your solution, you just got the cos 2x minus getting 1 minus cos minus, okay, without getting the O equation, you just got half part of it, which is cos 2x. Is it okay as well?
we got the whole thing, even we got this, which is our question.
I'm asking, or like when you try, so you need to prove the whole question again.
Yes, you are giving evidence of why that thing is correct.
Sir, can you do another question involving that concept?
So we have one here. Find x. So first thing, you let theta to act sine root 3 over 2. So if I have arc sine, it's the same as saying sine inverse root 3 over 2. So this is theta. So sine theta is the same as root 3 over 2. I'm sure you understand why I'm saying sine theta. So
Yes,
if
sir.
exactly, on the calculator when you're punching, if you have sine theta is equal to 3 over, then you want theta, you take the second function. So what is theta then? Theta is equal to 60. So you got the function, since we say that theta is equal to this thing inside. So we have cos 60 is equal to x plus root 2. What is cos 60? For 60 is root 3. For 60 is half actually. For 60 is half, which is equal to x plus root 3 plus root 2. So half minus root 2 is equal to x. So we have found the value of x.
Sir,
You know,
that's all.
you know,
I'm saying that's all. Like you can't find a common denominator.
why should you find a common?
Yeah, where we say 2.
But you need to find a common denominator, then what? Nothing. They want you to simplify to a nice thing.
So I didn't understand how you got the sine theta from sine inverse.
From sine,
From sine inverse to sine theta.
you punch in the calculator. What is sine inverse of root 3 over 2? Is easiest.
I mean,
Sa pang ka-previous board mo coach. All right, thank you.
Find the area of the shaded region. Find the area of the shaded region. So first thing, you equate, since this is y, this 2 is y. So y is equal to itself. So you equate x squared to 8 minus x squared. So you have 2x squared is equal to 8. Divide by 2, divide by 2. So you get x squared is equal to 4. So that x is plus or minus 2. This means that this is negative 2 and this is positive 2. Then from there, You integrate now from -2 to 2 to get the area. What do you integrate? This function minus this function. So 8 minus x squared minus x squared.
Excuse me, sir.
Hello?
Did you just change the y into x squared? Why?
We didn't change the y into x squared. Y is equal to x squared.
Then why is that x squared is equals to 8 minus x squared again?
Because y is also equal to 8 minus x squared.
Oh, all right, thank you.
So that here we get -2 to 2 of 8 minus 2x squared dx. We can now integrate. So we have 8x minus 2x3 over 3. And substitute in this order. So we have 8 by 2 minus 2 power 3 over 3 minus 8 -2 minus 2 -2 3 over 3. This is equal to 16 minus 16 over 3 minus
So
hello.
minus 2x squared. Where is the x squared coming from?
We're subtracting negative x squared minus x squared.
Okay, thank you, sir.
So here we get 16 over 3. When you expand, you will have 16 minus 16 over 3 plus 16 minus 16 over 3. This is giving us 32 minus 32 over 3, which is equal to 3 by 32. We get 60. We get 96 minus 32 over 3, giving us 64 over 3 units squared. That is what we call the area. This is called application of derivative of application of integration, finding the area.
On step 2 after sorry, but I've not seen you combine the x squared and that on that part for you to come up with 8 minus 2x squared. I'm not seeing how you combine.
Which combination did you see? Well? Network is cutting out. Can't even get.
Sir,
Hello.
she's saying that that combination, like there from the first one, then you got 8 minus 2x squared. She thought as though you're combining the two, but how have you come out with it?
8 minus 2x squared.
Yes, that's what she's saying.
If this is 2 and this is 8, what is the distance of? What's the height of this? No?
Yes, sir. Okay, you've done negative x squared minus negative x squared for you to get to x. But those are two different functions. You're supposed to subtract that one from
Yes,
that.
we
Now,
subtracted.
how is it possible?
We subtracted this minus x squared. Which is 8 minus 2x squared. Okay, for now you can rest. Try to go through this.
Number 12.
If you stop them, you don't get the same answer. Do them in the order.